Welcome back. Now we will solve this exponential equation right here. Right, so we are trying to find all real solutions of this exponential equation. We have a to the power x plus 27 to the power x over 12 to the x plus 18 to the x equals 7 divided by 6. All right, so the first observation we make here is that everything is can be written as a combination of a power of 2 and a power of 3. So we say let 2 to the power x be a and 3 to the power x be b. All right, so then this 8 to the power x right here, this is actually 2 to the power 3x, which can be written as 2 to the power x to the power 3. And in a similar way, we have 27 to the power x, it's 3 to the x cube. And we can rewrite the denominator in terms of 2 to the power x and 3 to the power x. So this equation right here with the substitutions a and b becomes a cubed plus b cubed divided by a squared b plus ab squared equals 7 over 6. All right, so next what we will do is we will use this formula for the sum of two cubes. So a cubed plus b cubed, this is a plus b, and then a squared minus ab plus b squared. So therefore we are going to plug in this formula in the numerator right here, and in the denominator we will pull ab out. So once we pull ab out, we will have a plus b also in the denominator. All right, now we can safely go ahead and cancel a plus b because a plus b it's a positive number, it's different from 0, so it can be easily canceled out with no problems. So this is what we get. This is what we have so far. All right, so now what we will do is we will cross multiply, right? So we will multiply by 6 this numerator and by ab the numerator 7 here, so essentially cross multiplying. And after we cross multiply, we'll get 6a squared minus 6ab plus 6b squared. And then we will have 7ab on the other side, which we will move to the left-hand side here, and it will become minus 13ab. So this expression right here can be factored as 2a minus 3b and then times 3a minus 2b equals 0. So we have product of two numbers equals 0. Either the first one is 0 or the second one is 0. If the first one is 0, we will get 2a equals 3b. And if the second one is 0, we'll get 3a equals 2b. All right, now we just remember that a was 2 to the power x, b was 3 to the power x. So this equation 2a equals 3b, it will become 2 to the power x plus 1 equals 3 to the power x plus 1. And similarly, the second equation here, 3a equals 2b, will become 2 to the power x minus 1 equals 3 to the power x minus 1. All right, so now we want to solve this equation right here, which is 2 to the power x plus 1 equals 3 to the power x plus 1. We can just take the logarithm in any base. So this power will come down in front of the logarithm, and we will obtain x plus 1 logarithm 2, for example, equals x plus 1 log 3. And we will obtain a similar equation for the second equation right here. Right? So these equations right here, this is only possible when x is equal to -1. Why? Because if x was not -1, then this x plus 1s could be cancelled and we would get log 2 equals log 3, which is not true. So therefore the first equation is only true when x is equal to -1, and the second equation is only true when x is equal to 1. All right, so now at this point I will leave it to you guys to verify that x equals -1 and x equals 1 will both satisfy this original equation. It's easy to check it for x equals 1. If x is equal to 1, we will get 8 plus 27, which is 35, divided by 12 plus 18, which is 30. So 35 over 30 will be 7 over 6. And it's not difficult to check it for x equals -1. All right. So you just need a pen and paper to plug in x equals -1 here and see that this equation is valid when x is equal to -1. So the solutions of the original equation, therefore, are x equals 1 and x equals -1.